Hey guys, my name is Mujahid, and this is the second episode of A Beginner's Guide to C++. In this video, we are going to go over basic commands, changing values, and if-else statements. Let's get to it. Alright, to start off, we have basic commands, and we've seen a couple of them in the previous video. For example, we are somewhat familiar with cout, and we know a little what it does, but I'm going to go over them again. Cout is for you to be able to interact with the compiler. It allows you to give an output to the console application. The main purpose is to view things. The way you use this is you go cout, you use the insertion operator, and you give a component. That component can be a variable, that can be a number. It all depends on how you want to do things. And you can then use the insertion operator again to insert another component. And then once you are done, you can just end your statement at there. But it is usually recommended to end your cout commands with end line because when you don't do that, things sometimes get messy. Another one we have is cin. And what this does is it takes an input from the user. So it's pretty useful if you're making an application where you need to be able to interact with the user. And the way you use this is you write cin and then you go with something like this. And then you name the variable. You need a variable to make use of cin because this is the way cin works. It goes to variables and changes their values. This is what this guy does. In here, I've made a small example. As you could see, in the main function, I've declared integer x to be equal to 150, and I would like to learn what x's value is. It's basically what I did in the previous video, but for demonstration purposes, again, I think it's okay to use this again. As you could see, cout, the insertion operator, and then in here, this is counted as a component. And if you surround something with this guy, the thing you surround becomes a string. So when compiler looks at this, this by itself is a whole and it is a string that has four components. For example, that is made of four characters: x, space, equals, space. And this is the second component I wanted to use. This is a variable and it is an integer. As you could see, we've just declared what it is. It is going to give me the value of x once I run the code. So we expect something like x equals 150. Let's try to run the code. All right, I run the code, and as you could see, x equals 150 is exactly what we've been expecting. This is what cout basically works. But what if I wanted to declare the x's value inside of the console? What if I wanted the user to decide what x is? Then we can use cin. And to do that, I'm going to go to the next line and write cin x. What this will do is it will give me a moment in the console application and it will take an input from me. And since x is an integer, it will only accept integers. For example, I can't just declare the value of x, something like hello or 2.5. It will only take integers. It will accept numbers with floating points, but it's not going to be right. If you give it something like 2.5, it is going to give you 2. Now that we've gotten the value of x from the user, let's copy this and paste it to print the value of x once more and try to run the code like this. As you could see, it is telling that x equals 150. It is because we didn't delete the previous command. Now we are going to redeclare the x. This is what we used in the command, and now we are going to declare it again in the console. I'm going to give it something like 250 this time. And if I press enter, it is going to give me that x equals 250. If you're curious, I can run it again, and this time I'm going to give it a value with a floating point. So let's just say 2.5. It is going to give us 2, just as I said. When you're working with a variable, you don't want the variable to always stay the same. You know, they are named variables because they have variety to them. You can change what their value is. And the way you do this in C++ is you go on and write the variable's name and then equal it to the new value you want it to have. The format is like this. And if you're working with numbers, C++ gives you even more options. You can use different operators such as plus equals, which makes it so you add another value on top of the value existing. So if I were to have a variable that is equal to 15 and I wanted to add 5, I would say variable name plus equals 5, and this would make it so the variable's new value is 15 plus 5, which equals 20. There's also this format which allows you to increase the value of your variable. It is pretty simple. It goes variable name plus plus, and you end this statement right there. All this does is it adds plus 1 to the variable you have been working. You can also use different mathematical operators such as minus or times or divided by. For example, if I were to use minus equals instead of plus equals, I would take the value away from the variable. I'm back at Visual Studio Code. This time we're gonna change the value of x. Let's make it 250 again. So if I want to do that, I just type the variable's name equals to the new value I want it to have. Now, if I were to run the code, as you could see, we have 215 here. And since x is an integer, I can use mathematical operations with it. So let's do something else this time. For example, let's add 200 to already existing value of 150. So we want to increase it by 200. I can just go plus equals 200. And this time, if I run the code, we are expecting to see 350. And as you could see, we have 350. There's one more mathematical operation which only adds 1 to the value of the variable you have, and it is plus plus. If I were to run the code, this time we expect 151. As you could see, we have 151, exactly what we've been expecting. I can instead use minus twice, and this time we are gonna get 149, just like that. Okay, let's get to if else. The way if works is it always checks the statement that is on top. For example, if I go if and give a statement, the statement in here is supposed to be a Boolean type of statement. So it is going to give you 1 or 0 or true or false. And if it is true, it will go down between those beautiful parentheses and it will run the code in between them and skip the rest. And if this statement is false, it is going to go for the else if and check if that statement is correct. If it is correct, it is going to run the code between the beautiful parentheses, and you can use as much as you want of these. And there's also else. This is kind of awkward to explain in a PowerPoint, so let me get to the compiler. All right, let's write a small code about if-else statements. All right, let's go for something like this. Let's declare an integer x and it equals 12. Then we can go in and say if, let's give a statement in here, x equals 12. If you use equal twice and in this format, it becomes a question. Does x equal 12? And the answer to that is yes, x actually equals 12. So this is a correct statement. Now I go down and I can write something like this. That means if we see x equals 12, we can understand that if statement was correct and the code in line 8 worked. Let's check for another thing. Let's go else if x equals 13. The way compiler reads the code is from top to bottom, so it is going to check if the condition in x was met, and if this is not correct, then it will check if x equals 13. And what if x doesn't equal 12 or 13? So let's add else. If you look inside the code, we can see that x equals 12, and inside of the if statement, we have does x equal 12. So we know that this is true. So the command inside of x will work. The line 8 will be run. As you could see, x equals 12 is what we've been expecting. Now, if x was equal to 13, then the statement inside of if wouldn't be correct, and we would check if the next statement is correct, which being does x equal 13. In this case, yes, x equals 13. So it is going to give us x equals 13 as a result. Let's run it. And as you could see, x equals 13. And if x were to equal 14, that would mean x isn't 12 or x isn't 13. So it runs the code that is inside else instead. As you could see, x does not equal to 12 or 13. Alright guys, here's the question of the video. The answer will be in the description, and feel free to do what I did today yourself. That's about it. Take care.